So we're making sodium formate for calibration of the Xevo QTOF. This is the exact formulation that we're doing. 1 mil of 0.1 molar sodium hydroxide, 900 microliters of water, 100 microliters of straight formic acid, high grade, and then 18 mils of 90% isopropanol water.
Yep.
And that we put directly into the C. I guess that makes up just enough to fill up the calibration C bottle on the instrument. And then we'll purge. We're going to go ahead and purge 3 times. Make sure that you are on reservoir C when you hit purge. And then you're just going to hit the purge the fluidic system here on C. We're trying to pump through the actual sample syringe. It's important to do the calibration through the same sample syringe that you're spraying your sample through so you get the best calibration. You have the method called up with a 0 volume injection with the metabolite tune that we want to calibrate. This is a 1 minute no injection infusion run with the combined, and it's positive mode right now, but there's a negative mode one as well. So it's just a continuum mode, MS1, feature only, 50 to 2000 with 0.25 scan. I don't think the scan speed is like required to be 0.25, but that's what we've chosen. And we are, again, not doing dynamic range enhanced here. So this is just in a regular MS1 continuum file. All right, you definitely don't want, there's no lock mass information or correction in the data file. So you want to make sure that in your lock mass events, there is no lock mass acquired. So the method events on this infusion, this 1 minute infusion with no lock spray added, the method events look like this, and we're flowing in at 50 microliters a minute on the infusion side with a combined infusion. The flow rate for this method, and this is what this looks like, there's really many differences here, all looks about the same, of course no collision energy. And then if we look at the method here, we're going to have a flow rate of 0.4 mils per minute. This is a 50-50 formic acid, 0.1% formic acid, water, acetonitrile. And then at the end, see we got the 11 on the curve. Right at the very end, it drops the flow rate down to 0.02 just to save solvent flow. But the whole flow rate is a combined infusion with your pump going at 0.4 mils a minute and the combined infusion on the syringe pump at 50 microliters a minute, and that gives you a nice signal with the right intensity so you can do the next step. All right, and there we go. Just going in, takes, you know, 10th of a second or so to get going. And there we go. It's just acquiring across that range. And then, how long did you do the average for when you do to make the spectrum?
Anywhere it's consistent.
Yeah, so we're a pretty high signal here. Right, so now we've acquired the data file, and we're just going to go ahead and create an average spectra across kind of where it looks like a nice flat region of data. And then that combined spectra, we're going to go ahead and process it using automatic peak detection. So automatic peak detection, you don't have to really change any settings, you just want to have the set peak detection automatically. That will go ahead and center the data. And we're going to delete the bottom one there, and then we're going to go ahead and save this spectrum, and that just saves it directly into the folder so you can access it later. Then you're going to go into the IntelliStart window here in the console. In the IntelliStart window, you want to make sure that you are in the configuration mode, not in the normal mode. When you're in the configuration mode, you're going to be able to create a calibration profile. Alright, so you want to go ahead and make a new custom profile across the mass range. Profile editor, you're going to select the one that you just created that has the correct mass range. And then in here is where you're going to go ahead and load your data file. And we're just going to do positive mode first. Let's just do one load at a time. And you can make sure that you find the file we just saved the spectrum for, and hit OK, and then that's going to be loaded with the sodium formate positive mode. Again, we're doing the manual use previously acquired data and identify the peaks manually. So we're going to just hit OK and then close it and hit next, and then make sure you're just selecting the positive mode calibration to perform, and hit next and then start, and it should automatically go through the data and find all the peaks. You can see we got a really good, almost no error across the range except for down low where we're kind of missing the peak down low. but you can see we're within 1 ppm across the entire range, it looks like. And so this should be a pretty good cal file. So we'll just go ahead and accept this. And now we are all passed, and the instrument should be well calibrated.